The REACH legislation states that the safety of newly developed materials and the related particles need to be assessed beforehand. For that, the common approach was to treat rodents with various particles and to quantify their deleterious effects in their organs. For example, if no granulomas were observed in the lungs after the instillation of a material-derived particles, the material was not considered as unsafe as it passed the test. As you know, we need to be ready for more and more legislation, drastically limiting animal-based experimentation to favor alternative models such as in vitro models. The aim of my PhD is to develop an innate B1 lymphocyte-based in vitro particle-induced granuloma model for predictive toxicology. When taking the example of silica particles, treated mice will develop granulomatous disease similar to what is observed in exposed individuals. The lungs are filled with collagen and granulomas which decrease lung function. Granulomas are cellular aggregates containing macrophages and other cells such as B cells, and granuloma aims to concentrate and isolate foreign bodies such as particles. The current paradigm of particle responses is based on macrophages. If macrophages fail to clear the particles through phagocytosis, they will secrete cytokines and growth factor, leading to granulomatous fibrosis. Interestingly, we have found that mice deficient in B cells were protected from developing silica-induced granulomatous disease. Among B cells, we have found that B1 cells and not conventional B2 cells were accumulating in the lungs when mice were treated with granuloma-inducing particles. For developing a 3D granuloma model, the combination of macrophages, fibroblasts, and epithelial cells leads to a granulomagenic particle-induced spheroids, which is organized in layers. When we have decided to use B1 cells, we have observed that B1 cells and not conventional B cells, B2 cells, also organize spheroids, as B1 cells cluster cells, but also particles, specifically granuloma-inducing particles. Moreover, we have found that these two models recapitulate the extracellular matrix remodeling environment as TIMP1 levels were elevated in fibrotic granuloma-inducing conditions. The goal of my PhD is to propose these models to industries for predictive toxicology and safe material development, as well as identify the targetable mediators by which B1 cells promote granulomas.